All right, I'd like to do one more example. And in this one, I am going to sort of skip over all that algebra in the middle. Really, the thing that's important and new to us is how we specify what y sub p should look like. So I want you to see one more example of us doing that, where things get a little bit complicated. So our problem is to solve y double prime minus 10y prime plus 25y equal to x squared e to 5x. And I also want you to see an example where we're actually not given those solutions to start with. And if you're not given those solutions, you need to make sure the first thing you do is solve the homogeneous problem. So we got to solve y double prime minus 10y prime plus 25y equal to 0. This is a constant coefficient problem. We know how to solve it. Really, the only hard part is remembering you need to solve it before you write down y sub p. In this case, we're going to let y equal to e to mx. So y prime is m e to mx, and y double prime is m squared e to mx. Then this gives us that the ODE 0 should be equal to y double prime, which is m squared e to mx, minus 10 times y prime, which is that m e to mx, plus 25 times y, which we assumed was e to mx. That's going to be m squared minus 10m plus 25 e to mx. Remember, we can sort of cancel out that e to mx. I'm just going to tell you that the quadratic function here factors into m minus 5 squared. That means we have m equal to 5, a repeated root. Which gives us the fundamental solutions y1 equal to e to 5x and y2 equal to x e to 5x. So now we know what y1 and y2 are. We need that when we write down y sub p to make sure we're not copying their functions. Now, we want to solve for the particular solution y sub p in the full equation equal to x squared e to 5x. We know from this equation that g is equal to x squared e to 5x. Y sub p is going to be a times whatever g looks like. So x squared e to 5x, that's my step A formulation of g. And then I need all the derivatives. So I've got b x e to 5x plus c e to 5x. When you take derivatives of x times e, you just go down powers of x until they go away. And so these two right here are my derivative terms that come from b. Now is where it gets a little bit complicated. I need to do that c check, that I don't repeat any functions that appear in my fundamental solution set right here. So I can't have e to 5x and I can't have x e to 5x. So I have both those functions. I need to deal with it. Here, bx e to 5x, I'm going to multiply by x because I want to try and get to a new function. But now, I already had x squared e to 5x. It's right over here multiplying a. So this function is no good to me. I actually have to multiply by x again, taking me up to bx cubed e to 5x in order to have a new function. So that's c, multiplying by x until something new happens. And then c e to 5x is a copy of y1, so I have to do the same thing. cx e to 5x is a copy of y2. That's no good. X squared and x cubed I already have, so this one's going to go up to power 4. Cx to power 4 e to 5x. Again, dealing with that copied function rule. But then at this point, I have the y sub p that I would proceed through the rest of the problem with. And I'm going to move to the next page. So go ahead and pause if you're still writing all that. And we're not going to do this whole problem. I'm just going to remind you that to find y sub p, we're going to solve for a, b, and c by plugging y sub p and its derivatives into that equation I wrote on the previous slide, yp double prime minus 10yp prime plus 25yp equal to x squared e to 5x. In case you want to know, the solution is a equals 0, b equals 0, c equal 1 over 12. And if you want some extra practice in this section, doing that would be some great extra practice. We're not going to do it in this video because the time it takes to do the product rule for x to 4 e to 5x would make you all never want to watch a set of videos again. So I hope you'll trust me or do it on your own. And then to finish out this type of problem, remember, you're going to do algebra for like 20 minutes right there. So always remember that at the end, you need to give me the general solution, which is y equal to c1, y1, plus c2, y2, plus y sub p, which from the coefficients I just gave you would be 1/12 x to 4th e to 5x. Sorry, so if you want to work through this problem, you could check that you get to that final answer. But that's everything we need to know about undetermined coefficients, so I will see you in the next set of videos.